Today we'll begin Chapter 15 and Section 15.1, which is an introduction to radicals. And to begin with, we'll take some terminology. The reverse operation of squaring a number is taking the square root. Of a number. And we say that if a number b is a square root of a number a, then that means that b squared equals a. In order to find the square root of a, you'll need to find a number that, when squared or multiplied times itself, will be equal to a. This symbol is called a radical. It looks a little like a division symbol, but it actually isn't. Although it is a take on division, just like powers or squaring a number is a take on multiplication. And we also call this a radical sign. And the expression that is either within or under a radical sign is called the radicand. And a radical expression is an expression that contains a radical sign. And we're going to make the agreement that if a is a positive number, that this symbol is what we call the positive square root of a. And then the other one is called the negative square root of a. And we will also make the definition that the square root of 0 is 0, which should make sense because, of course, 0 times itself is still 0. The square root of a, and this is very important, a negative number is not a real number, because by virtue of what squaring is, a positive times a positive will give you a positive. A negative times a negative will give you a positive. But there's no way to obtain a number times itself with the same sign coming out to be a negative. So for that reason, we cannot take square roots of negative numbers. So now we're going to find some square roots. And even though we could use the calculator quite efficiently to do this, the idea here is more that you understand how to break down radicals without using the calculator, because you can't do that when you're doing a radical with an expression under the radical or as the radicand. So the square root of 49, since 49 is 7 times 7, then we say that the square root of 49 is 7. And the square root of 25 over 16 is the square root of 5 times 5 over 4 times 4, which is going to be equal to 5 over the 4. And the opposite of the square root of 4 is the opposite of the square root of 2 times 2, which is going to be negative 2. Now this next one is a little bit tougher to figure out in your head, but take into account here we have 2 decimal places, which means that we must have multiplied a 1 decimal place number times a 1 decimal place number. So then that means that the square root of 0.81, since 9 times 9 is 81, then 0.9 times 0.9 would have given us the 0.81, and therefore the square root of 0.81 is 0.9. The next thing we're going to talk about is something called a cube root. And the cube root of some number is equal to b only if b raised to the third power is equal to a. And notice that in this case, a is not restricted to non-negative numbers, because we could take a negative times a negative times a negative, and we would get a negative answer. So it is perfectly all right to take cube roots of negative numbers. In fact, you can take even roots of negative numbers. You can take odd roots, which is cubes, fifths, sevenths. So at this point I'm going to give you some vocabulary. This is called the index of the radical. And basically what the index tells you is what exponent that this radical is related to. So for an odd index, in other words, 3, 5, 7, and so forth, negative radicands are okay. Because if we have an odd number of negative signs, we're going to have an odd product. For an even index, no negative radicands allowed. So it's the even indexes that we're going to have problems with. So just keep that in mind. 5. So for our next 3 examples, again, we could do these on the calculator, but we're going to break them down to help us see how that we're going to do the same thing with algebraic expressions as radicands. For this first one, we have the cube root of 27. That means we need a number times itself 3 times, that gives us 27. And we know that 3 times 3 times 3 will give us 27. So the cube root of 27 is 3. And by the same token, we know that the cube root of negative 125 is going to have 3 negative factors. And 5 times 5 times 5 is 125. So negative 5 times negative 5 times negative 5 is negative 125. So we say the cube root of negative 125 is negative 5. And then, as we used the fraction before, we're going to say that the cube root of 1 over 125 is 1 times 1 times 1 over, sorry about that, five times 5 times 5, which means that the cube root of 125 is 1 over 5. And that would have to be positive because we have a positive radicand, and this one was negative because we have negative radicands. Now, other roots can be found. The nth root of a is defined as the nth root, or n root of a, is equal to b only if you have n factors of b multiplied together will give you a. And again, this index n is even. If that index is even, then this is a restatement. The root is not a real number when the radicand is negative. Now, if the root index is odd, then the root will be a real number, even if the radicand is negative. So here we have a 6th root of 64. And probably the easiest way to break down these roots is to take the radicand, in this case it's 64, and start dividing by prime numbers. The first prime is 2, and 2 does go into 64 32 times. And then 2 will also go into 32 16 times. And again, 2 will go into 16 8 times. And 2 will go into 8 4 times. And then 2 will go into 4 2 times. And 2 is the first prime number, so we don't need any more factors of 2. And we notice here that we've got 1, 2, 3, 4, 5, 6 2's. So therefore, the 6th root of 64 is the 6th root of 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6 2's. Tells me they can come out in groups of 6. And that means that the 6th root of 64 is in fact then 2. Then we have the 5th root of negative 32. Now we're going to ignore the negative sign because it's an odd index. So we're going to know that all 5 of the numbers are going to be negative, but the question is going to be, what are they? So we're going to begin with the 32. And actually, since we've already broken this down to some extent, we have 1, 2, 3, 4, 5 factors of 2 give us 32. So the fifth root of negative 32 is going to be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 1, 2, 3, 4, 5 2's means the fifth root of negative 32 is negative 2. And then our last example, even though we could break down 16, we could break down 16 into 2 times 2 times 2 times 2. That's all the factors of 16. But this is negative 16. So our answer in this case is not a real number. In fact, we call it an imaginary number. And again, the reason is because if I have 4 positive 2's, I get positive 16. If I have 4 negative 2's, I get positive 16. So the square root of negative 16 is not a real number. Now we're going to talk about the fact that radicals can also contain variables. So for any real number a, the square root of a squared, since the square root of a squared is, by definition, the square root of a times a, we're going to actually say that the square root is the absolute value of a, because we actually have no way of telling from looking at that root whether the value of a was positive or negative. So we're going to just simply say it's the absolute value. And actually that has name in mathematics. We say it is the principal root. You'll hear of that again later. But basically you're going to say when you take the square root of a number, we're going to accept that it's the positive value of a. So we're going to avoid confusion, we're going to, for the rest of this chapter, assume that if a variable appears in the radicand, that's under the square root sign, that it represents positive numbers only, just so that we won't be confused about it. So now let's talk about how you simplify radical expressions that have variables. So here we have the square root of 64 to the 10th power. Now there is an easy way to eventually figure this out with a shortcut, but to start with, let's just go ahead and talk about how we break it down, and then we can talk about shortcuts. Since we know that 64 is 2 times 2 times 2 times 2 times 2 times 2. It's 6 factors of 2. And we know that x to the 10th is x times x times x times x times x times x times x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since we know this is a square root radical, that tells us that we can bring the 2's out in pairs. 1, 2, 3. Oops, sorry. And we can do the same thing with the x's. 1, 2, 3, 4, 5. And then if we go back to the regular notation, 2 times 2 times 2 is 8, and x times x times x times x times x is x to the 5th. Now, breaking the number down the way that we did here is already familiar to us. Breaking the variable down works the same way, but the shortcut here is that if you take the index of the radical and divide it into the power on the variable under the radical, you'll get the value of the exponent for that variable when it comes out from under the radical. So we're going to practice with this in the next one. We have the square root of negative 8x to the 6th. I'm sorry, we have the cube root. I said that wrong. We have the cube root of negative 8x to the 6th. So that's going to give us the cube root, once again, of negative 2 times negative 2 times negative 2. And then x to the 6th is 1, 2, 3, 4, 5, 6. So bringing those out in groups of 3, I'll see that I have one group of 3 negative 2's. And then bringing out the x's in groups of 3, I have 1, 2 groups of 3, which makes that x times x, or x squared. And again, 3 goes into 6 2 times. So then on this next one we have actually 2 variables. And it is a square root. And 25 is 5 times 5. And then a squared is a times a. And b to the 20th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, just about ran out of room. And then another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that when I bring them out in groups of 2, 5 times 5 is going to give me 1, 5. A times A is going to give me 1A. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs of B's, which is going to give me B to the 10th power. And again, 2 goes into 2 one time, and 2 goes into 20 10 times. So that's the shortcut method. So now we're ready for our last one, and this is another cube root, but it's a negative cube root. So this is going to be the negative